Yeah, so it's beautiful, beautiful haircut. It's the most glorious haircut of. Actually, you lucked out. Okay, I have seen many five side pledge haircuts in my day, and deliberately bad ones. Yours is at least symmetric. Um, oh yeah, the back is really bad. Okay, yeah. Well, it's a good thing headshots were yesterday and not today, right? Because otherwise you'd be. Why did they put this little gold stripe on there? Oh, okay. Well, uh, I may have a PhD in math, but I'm still sometimes an idiot too. All right, well, let's get to it. So, first thing, let's go over to our data and let's see what we got. So, let me switch the display over to Le Safari for people at home and window capture. Okay, I think I'm going to have to quit Safari and restart it. That's annoying. Le Safari. All right, and let's go to um, back to Dr. C's casino and see what data we ended up getting. So, Monsieur Nagava, votre data ne complete pas. Hmm. All right, well, so let's look at what we got. So what I did was I plotted. Well, I computed a few extra things. So for each of these, I computed the average of the mins, the average of the averages, and the average of the maxes. Okay, just to sort of try and smooth out individual variation. And so I did that for each of the four kind of sort of situations that we did. And then I just graphed these against the number of suits. Okay. And so let's kind of see what we're noticing. What do you guys notice about these curves? Let's just pick one. Let's start with the average time, the red one. It's getting larger with the number of suits. Wow, shock, right? Okay, so that part's not a surprise, right? That it requires more work to do more suits. Um, but how is it getting larger is maybe another interesting question. It looks pretty linear to me, right? I mean, almost a perfect straight line. And with the exception of that little crook at two, the minimum case is actually somewhat similar. Okay, so now that we have more data in, this is why I wanted us to have lots of data, right, Alex? Uh-huh. Let's look at the max times because there it's a little more interesting. What do you guys notice? Is it linear? No. So it's a little hard to see on the screen, but there is a little bit of a slope change right there. Not much, but there is one. Okay. So what function does that kind of look like, maybe? Huh? Either an exponential or possibly a like x squared kind of thing, right? Now, the reason I say x squared is because I know it has to be x squared, but for technical reasons. Um, Yeah, but the fact that the slope is also increasing, those of you who have taken some calculus, how many of you guys have had some calculus, by the way, or are in it now? Hands back up. Sorry, I was so rudely interrupted by skateboard dude bro that. All right, so are you in calculus, dude bro? Did you take calculus in high school? You are? Which calculus? One, one. Okay, excellent. Okay, so yeah, so the slopes are also increasing, and so that's what tells us it's not linear, but rather something else. Okay, and the question is, well, what is that something else? All right, so there's a lot of details here that we blew off last time, and so deliberately, I want to start going through the details. Um, in particular, how did you actually do the four suit sorting? Okay, so how did you guys do it? You shuffled the entire deck, and then what? Okay, so first thing you did was sorted all the suits. Okay, and then what? Okay, so you sorted all the suits, so you had all the hearts together, all the spades together, etc. Okay, then within each pile you sorted them, and then you picked up the appropriate piles because the order that we said that we would go with was what was it? Diamonds, clubs, hearts, spades was the order we chose. Okay, so that makes sense, right? That there was sort of a parallelism going on here. And let's suppose actually that I gave four of you a single deck to sort. Well, one of you could first sort into the individual suits, and then you could hand each person a suit and then put the results back together at the end, right? So there was sort of a parallelism that you could exploit. Did anybody else do it that way or something pretty similar? Okay, yeah, makes sense. That was certainly a good strategy. All right, what other ways did we use? Yes. Okay, makes sense. The fact that you knew that there were going to be precisely 13 cards was for each suit was helpful there. That you could sort of just visually, you know, allocate in your mind 13 slots and then kind of put it roughly where it belonged. Okay, any other kind of approaches, Ethan? Okay, makes sense. All right, what would be really silly or dumb ways to do this? Or maybe not dumb, but probably going to be a bit inefficient. One suit at a time, elaborate. Okay, yeah. So, which would be kind of so if you went through the entire pile, said, okay, I know I need to have the ace of um, diamonds first. So I'm going to search through the entire pile until I find the ace of diamonds. I'm going to pull it out. I'm going to put it in its spot. Oh, I know I now need the ace of clubs, so I'll start searching the whole deck for the ace of clubs. Okay, that would be probably a pretty inefficient way to do it. Um, but essentially, there, what your sorting method is actually a searching method, right? You're not actually sorting anything; you're just finding the object. Uh, so anyway, let's look at a couple of sort of classic algorithms for this. Okay, and we're going to do sort of repeat the process with the Google Sheet, but this time instead of keeping track of time, I want to keep track of the number of steps. Okay, so each time you move, swap two cards or something like that will count as a step. So now it doesn't matter how long it takes in terms of time, we just care about the number of steps. Okay, so I just grabbed here the spades out of my deck, and I'm going to do a crappy shuffle real quick because I can't bridge shuffle. My Can you bridge shuffle with a single suit? Well, it's a little hard, but all right. So I'm going to shuffle. It's probably not the best shuffling in the world, but then what I'm going to do is, this is why I've got the document camera over on the right. We're going to try using another new piece of technology. All right. All right. Well, that was really crappy. Yeah, I'll get the focus. It's probably tripping over my hand. All right. So here we go. This is a little better. All right. Let's see. Where's the focus? Autofocus. There we go. Okay, so I'm just going to lay out 4 cards for the sake of demonstration here, but obviously we're doing this for a larger number. Okay, so what we're going to go through are sort of a couple of classic sorting techniques that, so maybe one thing about this exercise that's a little different than if we were programming a computer to do it is that you guys have sort of a you know what poker cards are, and you, I don't know, have sort of some intuition about them, right? But let's say that I told you to sort these things and you'd never seen poker cards before in your life, right? It I mean, it would be no different than if I handed you a random 13 names and said put them in alphabetical order, right? You wouldn't be able to use the trick. Well, okay, I guess with if you had a fixed 13, you could say, okay, I'm going to think of the A's over here on the left and the Z's on the right, and then I'll kind of put things where I think they roughly should be. But how do you know that I'm not going to be a jerk and give you 13 people whose last name starts with R? So you have to look at the second and third possibly letters, right? I mean, I could do that if I wanted to be evil. Yeah. All right. So one algorithm to sort this is called the bubble sort. It's not particularly efficient, but it's sort of easy to understand. All right, so here's how the bubble sort's going to work. I'm going to start at one end of the pile, and I'll just start on the left end. Um, doesn't really matter, but that's the end I choose. So I'm going to look at the 10. Okay, so is the 10 less than or bigger than the 8? Okay, it's bigger than the 8, so I should swap them. Okay, so uh, I just did, let's see, 2 operations, one comparison and one swapping. Okay. All right, then I say, let me look at the 10 and the jack. Is the 10 supposed to be before the jack? Okay, good. Leave it alone. Okay, so it's bubbled to its, well, maybe not quite final position, but I've bubbled it basically part of the way. All right, now, in this case, then, what I would do is I would go back to the um, first card, and I would say, all right, compare it to its neighbor. Is it less than the 10? Yes. Okay, so I don't do any swaps, and in this case, then um, I'm finished. Okay, uh, we have them all in order. All right, so let me reorder these for sake of demonstration. Okay, into something where we'll have actually some more work to do. All right, so let's keep track of the steps. Step 1, comparison. Is king less than 10? No, so I need to swap them. So now we've got 2 operations. Okay? All right. Now I need to take the king and the jack. Is the king bigger than the jack? Okay, so there's 3. I just did a comparison and a swap. 4. Okay, king and 8. King's bigger. So I just did a comparison, and a swap. So we're up to 6 operations. Okay, good. Oh, um, no, because I heard a beep, so I bet you I hit. Oh, I hit the. Okay, I hit the 180 button. Why? Because my it was all backwards. For my next magic trick, right? I wonder if I could then like make it come from the side or whatever. Yeah. Um, oh, that's funny. Um, because like you guys were all looking at me like I was completely crazy. I'm like, what's the problem, guys? It's just cards, right? Okay, so what? How many operations are we up to? 6. Okay, so um, have I gotten the king? I've hit the end of the stack of cards. Okay, so I know that there's nothing more to compare the king to, and it may not be the case that the king is in his final position, but in this case it is. Okay, and so I start the process over with the 10. Okay, so um, is the 10 where it needs to be? Okay, it is with relation to the jack. Okay, so now what I'm going to do is I'm going to move, not starting over at the beginning because I can't, the 10's already where it belongs. I'm going to move to the jack. Okay, and I'm going to say, all right, jack and 8, are they in the correct alignment? No, so I'm going to swap them. Okay, and now the 8. Okay, so but what's the problem now? The 8's out of order. Okay, so like this is really inefficient because I'm going to go back basically through the stacks over and over again. All right, so let me show you guys an animation um, that will maybe make this a little easier to see. Um, so let's go to the bastion of all knowledge of Western civilization. Okay, so here's uh, kind of an animation of how this would look um, for, yeah. Okay, so just let's just kind of watch, right? Okay, so we're sort of scanning from left to right and flipping as we go as appropriate. Okay, and then we start over at the beginning. Okay, so watch what's going to happen with the 2. Do a swap, and do another swap. Okay, now the 7's in the good position, and then we start over from the beginning. Okay, so 1, 3. Right, so you guys kind of see why it's called the bubble sort, because you're sort of bubbling through, and the big cards or numbers are kind of bubbling to the top, but then you got to go and there's more bubbling and more bubbling. Okay, make sense? All right, so let's do this again with our cards just to make sure that we're clear. So, all right, so Jack and 8. First compare, oh, let me scoot this up a bit. Jack, oh, and switch the stream for the people at home. Okay. All right, so Jack and 8. Um, do I need to swap them? Yes. Okay, so I've done 2 operations, 1 comparison, 1 swap. Next set, Jack and 10. Do I need to swap them? Yes. Okay, so there's 2 comparisons and 2 swaps. Jack and King. Do I need to swap them? No. Okay. Now I'm going to start over. 8 and 10. Good. Okay. 10 and Jack. Well, so we know we're done at this point. Okay. Um, all right. So with 4 cards, right, it's not really all that illustrative, but the animation, does that give you a good sense of how this would, excuse me, be with 8 cards? And the document camera is basically 4 cards wide, so that's the most that I can do there. Okay, so what we're going to do, if you bust out your computer again, so because we're going to do some more data entry, um, is basically I'm going to take the exact sheet that we've got, okay, and I'm going to make down here at the bottom a new tab. Okay, so this will be for our bubble sort thing. Okay, so take out. We're going to do this just for a single suit because otherwise, um, well, actually, let's do it for. Let's see. Get out, say. Get out, say 5 cards. Okay, so shuffle your one of the suits and just take out after you've shuffled it. Take out the top 5 cards and set them down. And we'll do this for say 5 and 10 just to get a sense for it. Okay, so same spreadsheet as before. So we want to do name. Okay, so number. So this would be 5 cards. Um, and like before, we'll do 3 trials. Yeah, and keep track of the number of operations. So, what are the 2 types of operations you have? Comparison and swap. Okay, so just gonna maybe make a little tally on the paper or whatever as you're going through. How many comparisons did you do? How many sorts did you do? And record on the spreadsheet the total number of operations. Okay, so we're not going to distinguish between a comparison and a sort for the sake of just counting the total number of operations. Okay, all right, good. All right, but do it with this bubbly method. Okay, so here, unlike last time, I'm dictating thou shalt use this same method. Okay, make sense? All right, we'll get to it. Let's get some data. S'il vous plaît. Oh, we have an anonymous pumpkin has joined us today. Ah, that may be the only vegetable in the bunch. Or actually, pumpkins are they fruits technically? Vegetables? Fruit. Okay. Um, I don't. Yeah, it's just a sheet 2, right? So down at the bottom. Yeah. So same spreadsheet. as last time, but then click sheet 2 at the bottom.
Okay.
It's like a different tab. The bubble sort method, yes. Okay, yeah, question? Huh? Yeah, go ahead because you still have to do a comparison, and whether or not you do a swap just depends, right? So you're gonna write down the total number of operations, comparisons and swaps. Okay. Okay. So how are we doing at home, guys? Let's see. Looks like we got Farden here and Lurks. Who's Lurks? Saddest Kitty and Koi. Good morning or afternoon or evening or whatever time it is in Vietnam. Yes, there's a user called Saddest Kitty and another one called Lurks. I think those are bots. No? Yeah, just steps, not time. Yes. You still have to do that. Yeah. Okay. So, yeah, so like let's say that your cards just so happen to be in the right order when you put them down. Could happen, right? With 5 cards, it's the probability is not that terrible, but you still have to scan to make sure that they're in the right order, right? So think about it more like you're a stupid computer. You can't just look at all 5 things and simultaneously. I mean, you as a human can, right? But a computer would not be able to do that. Okay. All right. So when you finish this for 5 cards operations, we're going to do it again for 10 cards. Yeah, cannot type today. Hmm? Same spreadsheet, same as last time. Go to announcements. Announcements, yeah. There, there. And then scroll down to the a little bit. So you see right there where it says sheet 2.
Oh, okay.
Yeah, yeah, yeah.
Wouldn't we like get ones up at the front? Do we need to like keep going back all the way up to
You
the?
still have to scan, yeah. Well, like, let me put the animation back up. Right. Now, once you get the guy at the far right, because you've bubbled as you went, uh, so essentially what this does is it gets the biggest dude to the far right, and then you're worrying about, right, so, yeah, technical term here. Oh, it's nighttime, Koi? That's fascinating. It's almost as if the Earth is a sphere. Mhm. Um, well, okay, sort of, because you would have to. Yeah, in that case, you could stop. Um, yeah, you could, but you got lucky. Well, because that they happen to be in order. Yeah. Okay. Fourth. Okay. Five. Okay. You know, then the jack is in its final position because you didn't do a swap there. Okay. So now you start over with four. So you've got ace and six, good. Six and nine, good. Nine and ten, good. Ten's in its final position. And in this case, you don't really have to keep going, but ace and six, good. Six and nine, good. Nine, final position. Ace and six, good. Six, final position. Eight, ace, final position. Okay. Mm-hmm. No, because you know that at the end, if you don't, if you do a swap, they're in the right order. If you don't do a swap, they're in the right order. But you can stop at that point. All right, let's see what kind of data we're getting. Hunter, you're going to make me reprogram the entire spreadsheet because I only went down to row 20. Oh, that's all right. Hmm?
Different answers. I got the exact same answer twice.
Well, I mean, part of this just depends on how the cards were originally sorted, right? Like,
Really sure.
huh?
Because I got 9 moves every single time I went through.
Mm, that's a little surprising, but
Like I would go here, move on, move on.
maybe it just depended on how the sorts were, right? I mean, how it was.
It's always a count. So every time you swap, you don't count.
You do. A
So
swap is an opera.
if I don't swap, I don't count it.
Right.
Oh,
You did a comparison, but you didn't actually swap.
so only swaps count.
Right.
Oh, that's
No, no, no. Not only swaps count. Comparisons and swaps count, but if you don't do a swap, you don't count it because you didn't do it. Right. So when you have two cards,
oh,
you compared them. If you swap them, that's a second operation. If you didn't, then it's not.
wait. Oh, okay. But you still count a comparison even if you.
Yes, you still count the comparison, you just don't count the swap
Oh, I see.
because you didn't swap, right? But you still had to take time to think, is this equal or greater than that or not? And
How are people getting less than my number? Is my number too
uh, yeah, that means that they're not correctly implementing the algorithm, right? Because yeah, the minimum number ought to be for n cards should be n minus one comparisons.
or? Yeah, that's what I did. Consider times five. Or no,
Well,
times 10.
uh, sort of.
It was 10.
Hmm?
I went there 8 times
For 9 cards or 10 cards?
for 10 cards.
Well, because you'd have to do one, two, three,
Oh, but I also
four,
compared too. So I did 7.
6, 7, 8, 9.
Mm-hmm.
All right. So at minimum, it's going to take 9 operations for 10 cards. Okay, which means these mins are super shady data. This is one reason why I'm computing averages here to sort out the noise of, um, well, a couple of things. One, because you're human, there's the implementation of the algorithm. If we program this, that I wouldn't have to worry about. But two, there's the fact that, like, by dumb luck, they could end up in good orders when you shuffle them.
My data is fudged.
Um, your data is fudged. Yeah, fake news, Cole. Fake news. All right, so we still got a last little bits of data trickling in. Yeah, the maximum amount of moves is basically um, well, that would occur if the cards were in reverse order of sort.
Yeah, that's what I just did.
Yeah. Um, yeah. And what would it be if there were 5 cards? Like
Yeah.
20 ish, right? Okay. All right. So last little bit of data trickling in. Let's kind of take a. It's a little bit incomplete, but let's take a look at what we've got. Sort of on average. So on average, it took um, roughly, so I did here the average of the averages again, just to kind of smooth out the variation. Um, First off, what's the minimum number of moves that it could possibly take if there are 5 cards? 4, right? Because you got to do 4 comparisons. Because you got to do it pairwise, right? So first and second, there's 1. Second and third, there's 2. Third and fourth, there's 3. Fourth and fifth, there's 4, right? So if you have 10 cards, at minimum, how many operations should this take? 9, at bare minimum. Okay. That would only occur if you got really lucky and the cards happen to already be sorted. Okay. With 5 cards, the odds of that happening are not that terrible, right? 1 in 120. Um, but, you know, it could happen. It could not happen. Um, we're also kind of limited here by y'all's shuffling skills, because if they're anything like my shuffling skills, they're terrible. Um, you know, if I were like independently wealthy, I'd get like those auto shuffle machines and hand those out too, right? But um, alas. Okay, so let's sort of see what we observe. What about the maximum number of moves that it could possibly take here? Well, a maximum number of moves would occur if, by dumb luck, the cards were sorted in reverse order when you got them. Okay, in which case, at each stage, you're going to have to do a bunch of comparisons and a bunch of swaps, and it would turn out to be basically um, the square of the number of cards, I think is about right. Um, okay, but let's look at the average case because, well, that's what we want to make a statement about. Um, let's notice that the average number it took to do 5 cards was what, 11? Let's just call it 12 operations, 11 point whatever. Okay. Um, if I doubled the number of cards, what happened to the number of operations it took? Did it double them? Okay, let's just calculate the ratio here. What's the ratio of this C26 to, or sorry, I want the other way, F26 to D20, sorry, C26. Okay, so 4. I'm really gonna fixate on the number 4 because if I double the input, I've basically quadrupled the output. What kind of function do you know does that? From like algebra class. Oh yeah, it's a quadratic, right? So this thing looks like an n squared. All right, so on average, if I gave you 20 cards and had you do this, what would you expect to be the number of operations it took, roughly? Okay, there's a couple ways you can calculate this. Okay, if I went from 10 to 20 cards, what have I done to the number of cards? I've doubled it. So what would you expect happens to the number of operations, roughly? I quadruple it. Okay, so if I take the 51, whatever, right, multiply it by 4, I'd be basically talking 200 ish. Yeah. Okay, I could also compute that by saying, all right, well, going from 5 to 20 is quadrupling the number of cards, which should multiply by 16 the number of operations. Okay, and if I took, what, 12 times 16, well, that's 200 ish. Okay. Okay, does that kind of make sense? All right, so what we're looking at here is we're trying to kind of understand um, is sort of what function kind of bounds the situation. Okay, so on the average case here, right, what kind of function bounds our situation? Okay, so uh, if I were to draw, like, let's say, for example, let me go back to the first sheet here, right? If I were to graph this sort of information, then what I want to do is I want to find a function that this thing is always smaller than or equal to, and that function needs to be hopefully something simple. Okay, so something like um, n squared, or maybe n cubed, or n to the fourth, or something like that. Okay, um, there will be a slight tweak in there, and so on Monday, you guys are going to be in math class. Okay, so we're going to start talking about what's called Big O notation. Has anybody seen that before? Big O notation? Probably not. So we'll start to talk about that, and then we're going to start to talk about not just, I mean, because searching and sorting is sort of a good example of it, but um, all these searching and sorting algorithms fundamentally, like if I wanted to program these, or I wanted to give you guys really precise instructions, I would have written things like a for loop or a while loop. I would have had if then else statements. Yeah. Okay. And so effectively, we can, I mean, we don't have to toss the searching and sorting out the window. But then what we're doing is saying, okay, if you hand me a piece of code, a program that involves iteration and conditionals and stuff, how can I look at that and analyze what is it going to take in terms of its runtime, okay, in terms of number of operations? Uh, and then for that given piece of code, whether it's a searching algorithm or something completely different, uh, what can I kind of say is going to happen if you double the number of things to do or cards to deal with or something like that? Will it be just double the work, or would it be like our bubble sort here, where on average it was in squared kind of described the behavior of this thing? Okay, does that kind of make sense? Can't you're looking skeptical, huh? Okay, well, so our bubble sort method, so not this sheet but the other one, right? We saw that if you doubled the number of cards, it seemed to quadruple the number of operations, right? So the this process seems to be bounded or described or controlled by the function n squared, where n is the number of cards. Okay. Now maybe it's 2n squared, maybe it's 3n squared. That the 2 or the 3 is sort of not special. The square is what's special. Okay. Um, and maybe there's another sorting algorithm that on average is a little faster. Well, what could we say about how fast that algorithm runs, and how could we compare it to this other method? Okay. Now, you guys could probably think of a whole lot of other different sorting algorithms. Okay. And in a sense, we've already done a bunch of them, because when I had you guys do all this stuff Wednesday and then getting ready for today, you guys kind of invented what seemed like logical and efficient methods for yourself. Okay. Um, and some of those were basically or similar to the sort of classic, and there's a crap ton of these things, different sorting methods. So there's one, insertion sort, merge sort, and there's one called quick sort, which is, as you would expect, usually pretty quick. So anyway, all right, so that's where we're going to go early next week, and I think we should probably quit here. Have a fantastic weekend. Keep your cards with you, um, and I'll start to post an assignment or two for this stuff. And you guys have the what? The iteration and the recursion assignments are up on Canvas. Yeah. Okay. Good. All right. Have a great weekend. See you guys on Monday.